Now let's see the next property when we try to decompose, that is dependency preserving. So whenever you try to decompose the table, you should even see that all the dependencies are preserved. I mean, it is not a compulsory thing, but then it is better if you have it. Lossless is compulsory, but decomposition, this functional dependency preserving is not a must. Let's see this. I'll just show you what it is. Let us assume that we have a relation R which is containing some attributes. Let us say a1, a2, so on, an, some attributes, right? And on this we might have already a functional dependency f defined, right? From the semantics of the database we might get the functional dependencies, and now this functional dependencies f will be in such a way that they are applicable on R. Every table will have at least some functional dependencies which are applicable on that table, right? What do I mean by saying applicable? If all the attributes of the functional dependencies contain only a1 to an, then we can say that this particular set is actually applicable on that. Okay, now anyway we know that using the closure properties of attributes we can get all the functional dependencies which are possible, isn't it? So let us say all the functional dependencies which are possible and which can be derived from f or f plus. So what is f plus? It is nothing but set of all functional dependencies which can be derived from f that can be applied on this one. So we have seen that, right? Already we have seen how to derive all the functional dependencies which are valid from a given set of functional dependencies. We have already seen some examples on that, right? And now let us say we want to decompose this table into two smaller tables, R1 and R2, in such a way that R1 contains some attributes of this and R2 contains some attributes of this, and union of R1 and R2 contains all the attributes. See, first thing is, it is definitely, you should always see that whenever you decompose a table, you should not lose any attributes. That one I am not going to talk about it, because it is we always assume that every decomposition is attribute preserving, which means we are not supposed to lose any attribute. If you lose some of the attributes, obviously the data is lost, isn't it? So first thing is, attributes should always be there. So if you have n attributes here, a1 to an, all these attributes should be present either in R1 or in R2, right? Which means R1 union R2 should give you R. That is fine. And what we are trying to do is, we are trying to analyze the functional dependencies. Now out of all these f plus, all the functional dependencies might not be applicable on one relation, because some of the functional dependencies here might contain attributes which might not be present in R1, right? So let us call f1 as the set of functional dependencies which are subset of f plus which are applicable in R1. Are you following this? Which means some of the functional dependencies may not be applicable in R1 because it might contain some attributes which are not present here. For example, let us say R is like this: A, B, C, D, 4 attributes, okay? And here in R1 we got, let us say, 2 attributes, A and B, right? And here we have a functional dependency, A determines C. Now even though A determines C is a functional dependency originally present, you cannot apply A determines C here because C is not present here. That is what I am saying. Even though we have many functional dependencies here, all these functional dependencies will not be applicable on this table, right? Only some of them will be applicable. What will be applicable? The functional dependencies which contain only these attributes. Got it? That one I am calling it as F1, right? Similarly, F2 is a subset of F plus which contains all the functional dependencies which are applicable in R2, right? Now dependency preserving means, if I take F1 union F2 and if I try to derive all the functional dependencies which are possible from this, then I should get back the original set. This is the meaning of it, right? So if I can see that this happens, then such a kind of decomposition is called as dependency preserving, which means we don't want to lose any dependencies. That is the meaning of it, right? And now we have seen two properties. One property is lossless decomposition, which means whenever you decompose and whenever you combine, we are supposed to get the original table, not anything extra. And second thing is functional dependency preserving, which means whatever functional dependencies we originally had, we want all those functional dependencies later also, right? These two properties should definitely be followed whenever you try to go for any decomposition. And this second property, dependency preserving, is not generally so compulsory, which means even if we don't have this decomposition preserving also, sometimes we decompose the tables. What we really want is lossless. Decomposition preserving is, sorry, functional dependency preserving is not a mandatory thing, right? But still it is better to some extent if we can protect the functional dependencies without losing all of them, right? Let's see some examples, and now we shall decide whether a decomposition is lossless and dependency preserving, right? Let's see this. So why is it important? Because entire normalization is about decomposing the tables, and whenever we do decomposition, we want to see that these properties are followed. So before talking about the normalization, we shall see whether some kinds of decompositions are following these properties or not. Later we shall go for normalization. See, everything we are doing here just as a basics for normalization. Later these things will be important and applicable in normalization procedure. Fine.